Hi folks, and welcome to the video that contains some theory about OpenGL. I promise not to make this too boring, but there are some concepts that require further explaining before we delve into the coding. So here we go. OpenGL stands for Open Graphics Library and is a low-level API that allows a way of talking to the graphics card. It was released in 1992 by Silicon Graphics and used to fall under the OpenGL Architecture Review Board, or ARB, but now belongs to the Kronos Group. OpenGL is used for making games, simulations, and applications, such as CAD applications. You see a lot of OpenGL in stuff like medical simulations or architectural software, stuff like that. OpenGL is not a software package, but rather a graphics standard or implementation, limited only by your graphics card and operating system. Note, the open in OpenGL refers to it being an open standard instead of open source. All graphics functionality lies inside the graphics drivers, which are written and supplied by the hardware vendor. Programs made with OpenGL will communicate with these drivers accordingly. In the past, when 3D graphics were less sophisticated, OpenGL offered programmers a fixed function pipeline, which was merely a specific set of routines. Today, the programmable pipeline is used, where developers have more control on how their objects are rendered and used within OpenGL. So, who are these Kronos people? The Kronos Group is a non-profit consortium that oversees the development of OpenGL and its other APIs. It consists of over 100 companies that help set the graphical standard for OpenGL. This group also standardizes the OpenGL ES, WebGL, OpenCL, and the newly formed OpenXR APIs. Okay, so the fixed function pipeline is a set of predefined functionality that was used in the early days of OpenGL to create 3D applications. It was used in older versions of OpenGL up until version 3.0 and is now known as Legacy OpenGL. OpenGL had a set way of doing things via these statically predefined routines, and developers had little freedom in terms of rendering. The CPU was predominantly used for all draw calls and calculations. Note, the fixed function pipeline can be good for learning OpenGL as a beginner, but it is recommended to stay away from this form of graphics programming as much as possible. The programmable pipeline is the modern and current method of creating 3D applications and games with OpenGL. From version 3.0 onwards, the use of shaders, particularly vertex and fragment shaders, became more predominant. It offers more control, flexibility, and power than the fixed function alternative, and the GPU is predominantly used for all draw calls and calculations. Note, OpenGL 3.0 saw the beginning of the deprecation model, where parts of the core API were removed, and OpenGL could be set in either of two contexts, i.e. a backward compatible or forward compatible context. Before making use of OpenGL, it has to be set to a certain state or context. Now, there are two that you can set OpenGL into. So one is core, a core profile, and the other is a compatibility profile. The core profile only enables the modern core from 3.3 onwards up until the current version 4.6. No legacy OpenGL functionality is supported. For compatibility mode, this context supports the older fixed function pipeline and gives developers access to the older and newer functionalities of the API. Note, OpenGL cannot create its own context, nor can it create a window to render in, which is why applications such as SDL, SFML, GLFW on the older FreeGLUT, etc. are used to perform such tasks. Not much downloading and setup is needed for OpenGL. The development files already ship with Windows or Mac OS, as well as Visual Studio or Xcode when it's installed. Please note that OpenGL is not an SDK of any kind, so there is no actual installation involved. Again, all the functionality of OpenGL lies within your graphics card drivers. So at the very least, make sure your graphics card drivers are always up to date. Okay, I hope that wasn't too painful for you, but at least now you have a better understanding of the OpenGL API. Let's dive right into the next video and make a start on our graphical adventure. See you shortly.